this is Tim Cook, and this is the first episode of Healthcare IT Live, Google Hangout on Air. And we were supposed to have Dr. Ed Hammond here as a guest today, and he seems to be running late. Actually, I haven't heard from him today, so we're going to go ahead and have just an open conversation. And I do have a couple of topics. I'd like to, at some point, discuss the topic of the HL7 specifications being opened up in 2013, that announcement and what people think about that. So hopefully we'll have some more people join the panel and we can get on with that. At this time, Michael Bruno has asked some questions about Malim, and of course, as I told him, I'm always willing to talk about Malim, so we can talk about semantic interoperability and some of the differences between systems. So, Michael, do you have some specific questions?
Yes, but well, the first question would be, since I'm not familiar with Malim, how does it compare with the other kind of things like the OpenMRS, and what is different?
Okay, well, that's a good question. Then just to be, I feel like you're kind of interviewing me, but that's cool. This will work. Then it'll be a worthwhile program, no doubt. And thanks for your question. We want to be clear that Malim is a set of specifications that's more akin to HL7, Open EHR, and say ISO 13606. It's more in that family. When you talk about OpenMRS and OpenEHR, I'm sorry, what is that? OpenEMR is an application, and things like FreeMed and those type applications, they are specifically single-tier healthcare EHRs or EMRs. So they're a basic application, and they're kind of like, commercial or open source. They're all stovepipe applications, basically, that lock their data in, semantically anyway, into that application. So you only have the full semantics of the data capture when you're using that applications. And what I mean by that is they are typically designed around SQL database structures that have been designed with the table structures and the relationships between the tables. The connections there are all part of the semantics of how that data is captured and stored, as well as the rules and stuff inside the source code. So with that concept, you can see that each application captures semantics and can correctly process any of the data that it captures. But as soon as you start to try to exchange that with other applications, what happens is you don't have the same data structures, and you don't have the same source code that does the processing of the data. So that's where things like HL7 come in. HL7's history with version 2 in that area, the 2 point somethings in the messaging area, solved a lot of syntactic problems and some semantic problems, because they with their messages, you create the message using your data and some connections to control vocabularies like ICD or ICPC, and I think it's used mostly in the US, and of course SNOMED. So you add some semantics by utilizing those controlled terminologies or vocabularies, and others as well for drug management and manipulation stuff. There's a host of them, and that helps. But the messaging paradigm still doesn't allow you to exchange the semantics of what questions were asked at this point in time. And this is important because when you, as rapidly as healthcare information changes, and as important as it is for a long, long time, like in a lot of transaction systems, a transaction lasts, let's say, from the order point to the delivery point. And maybe some of that information is good over for historical reasons. You may say, okay, this is a continuing customer. But the full semantics of that data is not that important, like what all was going on in the world or in that person's life when that data was captured. Whereas in healthcare information, lots of stuff comes into play. Like what were the scientific questions that are asked, or what are the possible answers to that question when data is recorded in an EMR? Let's take ICD, for example. Look at the evolution of ICD over its lifetime. You know, not only has the codes changed, at least they've gotten really good at managing the changing of the codes now. It used to be pretty atrocious, and some codes were actually changed to mean something completely different over time. But irregardless of that history, even now, if you take a code, and let's take a code group, and I don't know ICD off the top of my head well enough. Let's say in this code group there are 5 options in that code group. So when somebody wants to assign an ICD code, they'll say, okay, in this code group we have these 5 options. Now let's say next year when ICD comes out, they add a 6th option. And so that changes the semantics of what were my choices when I recorded that data. So when you do data mining 10, 15, 20 years from now to find out about the medical history of this patient, those changes can be significant, because maybe 10 years from now there's 8 options for that same question. And somebody will want to know, well, why wasn't this choice made? And if we get into medical legal situations, it even becomes a bigger issue. Because when you start asking questions like, why wasn't this choice made? Well, in 2012, that option wasn't available in ICD that it is in 2018. So you can see how, and when you start multiplying this over the complexity of the human body and all the components and everything, you can see how this complexity grows and grows, and how important this becomes as science changes. So you have the complexity of the time, the ontology or the science changing, as well as the space. Where was this person? Was this person in a place like that had rampant communicable diseases? Or was this person in a place that was relatively safe? How could they have possibly contracted this condition? Or this condition could exist in, based on these symptoms, but if they're in a different place, it's more likely to be a different condition based on those symptoms. Does that make sense?
Yes.
So that's kind of my short intro into that. Now, the question is, how does Malim address this where some of the others don't? Well, in fact, OpenEHR does address this. I believe that HL7 version 3 could address this, but I don't think that there are many people doing it. HL7 version 3 has grown kind of out of this complexity that I think they wanted to do everything, and maybe it's because it's such a huge organization and they got people that focus on one issue and they want to do everything inside of HL7. So it wants to be like the owner of all knowledge except for maybe SNOMED and ICD. So I think that's why HL7 has grown to the complexity it has, and why, as far as I know, there aren't any implementations of real applications based on HL7 version 3 reference model. I have heard that there was one in an academic institution, and again, I haven't done a global search, to any kind of detail really. It just seems that if there were systems built on it, they would be easy to find. Because HL7 is such a big deal around the world for its messaging capability, for the historical part of it. So that's HL7. With OpenEHR, that's where we learned about the multi-level modeling approach. That's where you have really, let's go back a little bit. HL7 is kind of a multi-level modeling approach, but what it does is it doesn't restrict you to building models only by restriction. It allows you to build a model based on the reference model and then add stuff to it. So when that information is sent from one system to another, if they've added stuff that the other system doesn't know about, then it's not processable, right? I mean, that makes sense, right? Because the model isn't known on the other end. We take that and turn it around the other way. OpenEHR has a reference model, and the models, the content models based on that are they are only developed by restriction. So every data point that fits into an OpenEHR data model, which is called an archetype, then it has to fit into a reference model. It has to fit into a reference model system. So if your software is based on processing the reference model data, and any data that's coming in is guaranteed to be a restriction of the data that the reference model can process, then automatically you have interoperability. So now, why isn't OpenEHR more widespread? Well, for 9 years or so, I worked with the OpenEHR Foundation, the OpenEHR project, and gave lots of presentations in lots of places, and the constant feedback that I got was that it was over-engineered and too complicated to implement. And I also had another complaint about it, is that it was too focused on the EHR. It didn't allow, once you start building an application based on reference model, you're basically building an EHR no matter what. So when you have smaller applications, and of course over the past 2 or 3 years, things like you're talking about working on with the mobile applications, all the wearable devices that can now communicate via Bluetooth and stuff. All these devices don't need an EHR. They need a very simple data model that they know they can transmit their data in a semantically interoperable way out to some other device that eventually gets to an EMR or a PHR or those kind of applications. And so that's the fundamental concept of Malim. Malim took OpenEHR and trimmed off all of the stuff that wasn't needed for a fundamental healthcare application. So we got rid of a lot of the EHR specific stuff. So we have basic data types and simple structures in order to build concepts with. The other thing that we did is that between 2000 and 2009 or so, we had the XML language, the XML schema language, was advancing fairly rapidly over that time period. When OpenEHR was first designed, well, in fact, I don't think XML schema existed, or if it did, just barely. DTDs were the way to define XML data at that point. And then XML schema 1.0 was issued. It wasn't very robust in defining a data model. It could define some structured data, but not really a data model. So with the OpenEHR project, there was developed a domain-specific language called the archetype definition language in order to have a language to communicate the archetypes in. So there's an archetype model and a reference model. And so the archetype model represents the constraint model for archetypes, that are expressed in the archetype definition language. Now, when we started the Malim project in 2009, late 2009, we took a look at XML again, and XML 1.1 is available at this point. times better than XML 1.0 because it allows assertions inside the schema based on XPath statements. So you can do your, you can do those assertions will allow you to express constraints between different data elements inside the schema. Hello, Robin. We were just talking about the fundamentals of Malim. And so those assertions allow you to constrain things inside the data models in Malim. If you want to draw a parallel, the archetypes in OpenEHR we call concept constraint definitions in Malim. And they are an XML schema, 1.1 schema. And they are based on an XML schema reference model. And so, those concept constraint definitions, or CCDs, are just like archetypes. So now you have something that we don't need to define our own archetype model and our own domain-specific language. Plus, we get all the tools that are available for XML, all for free. So it really made the Malim project much more implementable to a lot more people, using the same concepts that OpenEHR uses, but trimming it down, making it, giving it a broader appeal, so you can build models for any kind of devices, as well as use, off-the-shelf tools, open source tools. That answer some questions?
Yes, definitely.
Did it bring up any more questions, I hope?
Well, of course now the question is that complexity that you're talking about, isn't it because of the complexity of the subject itself? I mean, if you're going to implement an actual application, for example, using those protocols, you're gonna need a battery of experts. Also, not only, experts in the field in order to properly implement that and make it interoperable. Absolutely.
Absolutely, and that brings up a great point. That's when you get into the knowledge modeling part of it. So this stuff doesn't come for free, because you're right, that is the complicated part. We are fortunate enough, though, to be at a point in time in health informatics where there are lots and lots of models that are conceptually designed. If you know what I mean, if you take like the HIE models, the Health Information Exchange models, they have this group of models that are conceptually defined, but they haven't been applied to a computational model like an XML schema yet. Okay, they've been implemented in software in lots of different systems, but those models aren't transferable. Like, you can take an XML schema and you've got a Java application, I got a Python application, and my friend's got a Ruby application. I can take that XML schema and we can all generate bindings to it and create source code for our application that works for that same model without doing anything else. I mean, the tools are there. You've got Pixby and Jaxby and whatever Ruby's got to generate a content model from that XML schema. So how do we get to the point of having the experts define those models? That's one path, the HIE models. The other thing that we've done with Malim is we have some examples, and I'll talk about the way that we can openly exchange these actual CCD schemas in a minute. But we have some examples of where we've taken from the National Cancer Institute in the US, and we've taken their common data element definitions, and then they have where they combine those into one concept called a CRF, and I forget what CRF stands for. We take those And so, and you take the CRF and you define a single concept using their common data elements, and we have a tool to do that with. So you can take the Cancer Institute's concepts and automatically generate schemas from them. And so now these schemas that define these concepts, the concept constraint definitions, or CCDs, what we do is, and this isn't mandatory, you can keep your schemas to yourself once you design them if you want, but in order to make them more widely shareable, we have a website, a content management system website called Healthcare Knowledge Component Repository, or HKCR.net. And up there we have quite a few examples. In fact, we all have all of ICD-10 grouping have now been converted to CCDs and are available there. And like I said, we have some of the National Cancer Institute CDEs are available there. And so we can all share ones that we've created through that website. And they can also be translated as well using the common GetText type translation tools. So the text within each of those schemas that can and should be translated can be translated and shared as well. So like in your case, you probably use French and English both, I would assume. I'm guessing here. I've never worked in Haiti, so I don't know. But so French. Yeah, so if you use just French or French and English, you could take those and translate them. And that's using, again, common off-the-shelf tools from the open source GNU project. The GetText tools are used, very widely. So that's how we build models. Now, of course, all models aren't going to suit everyone, and here's another major difference between Malim and OpenEHR. Everybody, as you travel throughout the world, what we found is that it is almost impossible to gain consensus on what defines a certain concept across the medical domain. There are some that are pretty well defined, but there are lots of them, and especially when you get into building an application that has one specific purpose, people want to be able to modify that concept slightly to fit their application. And so what we found was in OpenEHR, there is this centralized concept that there is one archetype per concept, and that's how the name spacing of archetypes work. And then if you need something different, you specialize that specific archetype. But a lot of the projects run into problems with that. So, and I don't want to get into any more detail than that. We can cover that by interviewing some knowledge modelers with some experience. In fact, we've got some on the list that can talk about specializing archetypes and some of the complexities. But so you've got this idea of one centralized concept that has been reached at by consensus. In Malim, the way we got rid of that problem is that by using UUIDs to define each schema, we can have as many schemas for any one concept as we want. Now, while this may sound confusing at first, really it's not. And here's the reason why. Because you're going to have a handful of concepts for your application. CCDs is that you can have multiple CCDs that define essentially the same concept, but may be structured a little bit differently to suit each individual application. And let's say your application takes 10 CCDs to satisfy your data needs, and your friend over here has an application that takes 15 CCDs to satisfy his needs, and then one day you need to share information back and forth. So when you want to transfer the information for one concept to him, he just needs to pull your CCD, and since all paths inside the CCD are UUIDs, they are all guaranteed to be unique. So there's never any confusion. So in your queries, the only thing that you have to do is, like if you're going to do data modeling on, I'm sorry, if you're going to do like some data mining on some of this that has these mixed systems information, which is very common. You talk about aggregation systems and stuff like DHIS. Then all you have to do is be able to say, okay, in this query, I know that I have these 3 CCDs that have the same data point, although they're defined differently. So when you do your query consists of those 3 different UUIDs in that query. I hope that doesn't seem complex. It's really not that complex when you define the queries.
Okay. Now, is there a concept of, for example, when you're talking about the context of the data, do you see that we could have, like, because, you know, in the tropical zones, or in a different context than like up in the north, so that the way that, have you seen some movement to define some specific context for tropical areas, tropical diseases, for example, these areas compared to the north?
Sure. As I said, I live in Brazil. I'm from the U.S., but I live in Brazil, so I have some familiarity with these differences. In fact, you know, just the cultures, just the difference in culture changes how these things are conceived, you know, how they're thought about. And so when you were talking, you're asking about the context, sure, and that's part of the spatial context. That's what I was talking about earlier. Where is this person in the world? What geographical location are they in? What culture are they in? You know, those things make a difference in the concepts. And that's why it's so difficult, like with the OpenEHR model, to define one archetype as a core concept and then specialize it for everybody.
Right.
So I don't know if that answered your question about context or not. One thing I didn't cover is that with the CCDs, in addition to them, you being able to define like enumerations in the schema and stuff, we also include RDFA links in there so that you can mark up your schema basically with RDFA links into ontologies. So when you define the semantics for that schema, when the knowledge modeler says, okay, this is what this concept constraint definition means, they can also include those links into whatever ontologies apply. So when they transfer that data, then that schema goes with the data, or it exists on an open place with a namespace, like on the hkcr.net, and we call that Hacker, on the hacker.net website, so that you don't actually have to transfer the schema. You know, you just transfer your data, and the instance data automatically points to the correct schema. So it makes it very easy to exchange data between different sites. You just have to exchange that one data instance.
All right. All right, thank you. I think now I'm going to have to leave.
Okay.
I thank you for your time. I will be making more research on MELIM so that I'm more prepared for the next time that we have to talk.
Well, I really appreciate the conversation, as I said, and I appreciate any opportunity to talk about MELIM. I would just ask you to go ahead and go to the forums page on the website and join the forums. If you have any questions at all, ask, and someone on there will give you an answer.
Thank you.
Thank you.
Right. Have a good day.
You too. Bye-bye, Michael.
Bye. Bye.
Hi, Robin. I can't hear you. No, I'm sorry, I can't hear you. Well, we made it to the half-hour mark. We were hoping to have Dr. Ed Hammond on and ask him some really pointed questions about HL7 and open sourcing. And we weren't able to do that. I hope he's well, and maybe we can have him on at a later date. Next week, we have Dr. Mark Spohr that will be with us. And let me do this officially here. Let me get his titles. Gosh, he's done lots of things. Dr. Spohr is going on 20 years as a managing director of his consulting, I believe it's consulting company, Medical Informatics Incorporated. And I met Dr. Spohr first while he was technical officer in IT for global issues with the World Health Organization, covering things such as e-health architecture, surveillance and monitoring systems, indicator management, health informatics standards development, and really enjoyed working with him during that time. And so we look forward to him. That's December 6th at 3 p.m. Pacific Time, 2300 UTC. And we'll see you all next week. Thank you so much.
All right. Thank you. Thank you, Tim.
Bye-bye.
Bye.